This is Chrisferb, and I'm going to review how to calculate the required sample size for a confidence interval, taking into consideration the amount of error that's acceptable. Okay, we'll get started. A manager is interested in estimating the mean pounds of flour purchased per month. He would like his estimate to be within plus or minus 0.5 pounds per month, and would like the estimate to be at the 99% confidence level. Assume the standard deviation for flour purchased per month is 4 pounds. What sample size is required? So, of course, we could have any type of sample, but when you have a certain amount of error, then we are limited with our sample, and it has to be at least large enough. Otherwise, we end up with a huge amount of error. Okay, we'll get started here. So for this problem, our error is 0.5 lbs pounds, and our standard deviation is 4.0, and we have a 99% confidence interval. So really for this problem, it's kind of a basic formula that we're going to apply. Okay, and what this turns into, this 99% confidence interval turns into, is we turn that into our z-score. And our z-score, let me get the table out. So we'd have 99% confidence interval, and I'm using my, I guess I'd call it a modified alternative z-score, meaning it's a half table z-score, and it was the 99%, and it was for the confidence interval. So what we do on this one is we are looking for our 99%. Now I have it written right here off to the side. I'll zoom in. Now, most people's z-scores won't have this box. Z-tables won't have this box right here on the side. And what you'd do is you would find this value right here, which would equate into 2.57. On this table that I'll provide, and it'll be available in the additional documents for this video, you'll see here what it says is, it says 99% confidence interval, 2.57 z, and it shows how that works out, which is 0.4949 plus 0.4949, and that is how you end up getting the probability that is equivalent to the z-score that's listed. So we're looking for 2.57. That's our answer. Okay, 2.57. Okay, I'm going to back this out again because I was zoomed in. Okay, so now all that we do is we have a formula, and this is the easy part. So to calculate n, or the sample size that's required, all that we do is this. So it's z squared multiplied by standard deviation squared, and then the error squared. And for our problem, it is 2.57 squared multiplied by 4 squared. Then our error is 0.5 squared. And this ends up equating to 424.36. And if you're actually looking for the sample size required, what you would do is you round up, because if you rounded down, then you would actually not have enough, because this is what this is saying is we have this fraction, so we want to round up. So what we actually have is it would be about 425. One other thing real quick, with this formula, it was interesting. I was kind of researching this formula, and there's another way to write it. So it's considered, for some reason they considered this was actually easier to teach than this other method, which I'll show you. Or I'm just going to say you can do this. And I actually like this one better, but it's up to you. So it's Z times standard deviation and E. You just square the whole thing. It's up to you how you do the calculation. So that's it. We to do the confidence interval with, let's see. So he'd like the estimate to be within plus or minus 0.5 pounds per month. And would like the estimate to be 99% confidence interval based on the information that's provided. The N would have to be 425. So it's a pretty big sample. But you see the confidence interval right here is pretty large. So we would have to have a big sample. Okay. Thank you for watching.